seasonal relatives are a set of numbers that essentially serve three purposes. One, they communicate a seasonal pattern. Two, they can be used to deseasonalize data. And three, they can be used to seasonalize data. This problem concerning the website and the unique number of users or appearances each day asks us to use a set of seasonal relatives for each of those three purposes. Let's take a look. Below are the seasonal relatives that describe the weekly fluctuation of the number of distinct users logging into a website daily, also known as the number of unique appearances a day. So here is our index right here, a set of numbers. Now, first, communicating a seasonal pattern. That's being asked about down here. Generally, what is the busiest day of the week for unique appearances? Busiest day of the week. And what is the least busy day of the week? Oh, okay, now let's back out for a second. Not just this particular set of relatives concerning the unique number of appearances, but any seasonal relatives. How do they communicate a pattern? Okay, there will be one value or number for each season in the pattern. And notice the season doesn't have to be spring, summer, winter, or fall. In this case, the regular repeating pattern is the day of the week, the days of the week, so there's essentially 7 seasons. Okay, now, if a number, for instance, Monday, it's 1.25, if a number assigned to a particular season is substantially larger than 1, that is indicating that that's a very busy time. That's a very busy season. It's a very busy period. If it is just the opposite, below 1, that is indicating, ooh, that's a very quiet time routinely or repeatedly, right? That is not a busy period. Now, what part A asked for is what is the busiest season, so to speak, or the busiest day of the week. On this website, look for the largest number. Let's take a look. For busiest, look for the largest number, and actually I don't see anything larger than that 1.25 for Monday. That makes it the answer. Monday is the busiest. Although part A did also ask for what's the least busy day of the week. Similar exercise, just look for the smallest. And I don't see any smaller relative than that 0.66, which belongs to Saturday. Okay, Saturday is the least busy. On this website, routinely, we expect that Saturday will be the quiet day in terms of the number of unique appearances. All right, now that was just communicating the pattern. What's it look like when we busy, when we quiet? All right, second purpose for seasonal relatives, to de-seasonalize data. That's part B. Last week, 750 unique appearances were observed on Monday. All right, we're going to need that number. Followed by 650 on Tuesday. De-seasonalize, see? It asks for it straight out. For comparison to each other, what does this suggest about Monday and Tuesday? All right, first off, the de-seasonalizing. Monday. Last week, on Monday, there were 750 unique appearances. That's an actual. To de-seasonalize actual data, to theoretically extract the influence of the season from the actual observation, you divide by the appropriate seasonal relative. Okay, so we want to de-seasonalize that 750 that I just wrote down. We'd say 750 divided by, we have to look up the relative 1.25 for Monday. We'd say 750 divided by 1.25, I get 600. All right, then what about Tuesday? Well, it says the actual was 650. To remove the influence of the season, what is the de-seasonalized value for Tuesday? We just retrieved Tuesday's seasonal relative, which is 1.01. That comes out a little messier. I get like 643.56 some odd, basically 644. All right, now that has partially answered that part of the question. The 600 here and the 644, those are deseasonalized numbers. All right, so first off, just reporting those values is answering part of the question. But the question also asks, what does this suggest about Monday and Tuesday of last week, which kind of suggests in turn, like, well, why do we bother to do that? What's the 600 and the 644 supposed to mean? All right, here's the theory. The theory is if the difference between the original 750 on Monday dropping down to 650 on Tuesday, we're talking about last week, was due solely to, well, yeah, routinely if you look at the index, Monday is our busiest time, so we would expect Tuesday to be quieter. If the actual 750 drop to 650 was due only to the season, then when you deseasonalize those two numbers, they should become very, very similar to each other. We noticed that in this problem, that did not happen. They're not too terribly dissimilar, but one of the things that concerns me is that when we deseasonalized Tuesday, it actually went up above Monday. Okay, so what is that suggesting? It's suggesting that there's something else at work here other than the usual seasonal fluctuation. That's all that it's suggesting. Okay, if it was just the usual Monday to Tuesday fluctuation, when they're deseasonalized, the two numbers would become very, very similar to each other. They didn't. The low number actually jumped above what's generally the high number. Maybe they had a quiet Monday compared to Tuesday, or maybe they had a busy Tuesday compared to Monday. We can't tell that from this. We would have to look at more data. But what we do know is that there is some influence there last week, other than just that natural fluctuation of the season. Okay, now that's deseasonalizing. You generally deseasonalize data in order to compare unlike seasons, like Monday and Tuesday. The third use or purpose of seasonal relatives, part 3 of this problem asks for: a manager has forecast for the first full week of next month. Okay, so it's a forecast. An overall number of 3,500 unique appearances will be recorded throughout the 7 days of the week. So we have a forecast. I'm just going to note that to the side. Okay, so for this future week, we have a forecast for the entire week. We expect 3,500 unique appearances. Okay, based on this estimate, this one, which of the following is the most logical estimate of the number of unique appearances on Thursday of that week? What is the most logical estimate of the number of unique appearances on Friday? Okay, well, let's work on Thursday first. You have this forecast here for the entire week for 3,500. So first, let me suggest something. That's for the entire week. There's 7 days in the week. If you divide 7 into 3,500, you get 500. Oh, so by forecasting 3,500 for the entire week, we are implying an average of 500 unique appearances each day because there's 7 days out of the week. Yes. Now, that wouldn't be a very good forecast for Thursday all by itself, to just say, well, then on Thursday, why don't you expect 500 people? Because we know that the days of the week, generally, the number of unique appearances is not the same. A daily forecast of 500 would only be appropriate if, in fact, we generally got the same number of unique appearances each and every day of the week. And, you know, when we started with this whole thing right here was telling us that that's not actually true. Oh, so this 500, where we just divided the larger forecast equally, is a deseasonalized number. Okay, as an estimate, it's flat. It is naive of the seasonality, the fact that Mondays will be busier than Thursdays and all that. What we want to do in order to finish this forecast for Thursday is we want to introduce the seasonal influence. How do you do that? How do you take a deseasonalized flat number and spice it up with the specific seasonality of that period? you multiply by the seasonal relative. Okay, to deseasonalize, we divide. To seasonalize or add the season, we multiply. We were looking at Thursday, right? Okay, so Thursday, what we do, let's go back to here. Look up the seasonal relative for Thursday, 0.09. Take that 500, it's rather flat, spice it up, times 1.09. I get 545. There we go. 545. That will be our forecast for Thursday. Now, this problem also asked for Friday, right? Okay, well then on Friday of that week, we would expect, first we start with sort of like the base, flat, naive daily forecast, 500, and then we multiply by, I need the seasonal relative for Friday, 0.94. So this times 0.094, I get 470. There. Somebody has forecast overall there'll be 3,500 users this week. So, or that future week. So what we are going to forecast is on Thursday of that particular week there'll be 545, and then on Fridays tend to be a slower, less busy time, there will be 470. Remember, to deseasonalize you divide, to seasonalize you multiply by the seasonal relative.